Good morning, Dr. Buhaida. My name is Ying and my metric number is AP170396. This is a video for step 6, which is georeferencing topo ships and scan maps. For the first, I have downloaded data from here. In the first step of this tutorial, I need to open QGIS. Georeferencing in QGIS is done via the Georeferencer GDAL plugin. This is a core plugin, meaning it is already part of your QGIS installation. The plugin is installed in the raster menu. I click on raster and I click on Georeferencer. The plugin window is divided into two sections. The top section where the image will be displayed and the bottom section where a table showing your GCP will appear. Now we will open our JPG image. I go to File and I click on raster, open raster. Then I browse the image that I have downloaded just now. I see the image will be rooted in the top section. I can use pen, zoom in and zoom out to learn more about the map. Now we need to assign coordinates to some points on this map. If you look closely, you will see coordinate grid with markings. These are latitude and longitude. Before we start adding ground control points, we need to define the transformation settings. So I go to Setting and I click on Transformation Settings. In the Transformation Settings dialog, I choose the transformation types as Polynomial 2 and I click Select CRS button next to Target SRS. If you are georeferencing a scan map like this, you can obtain the CRS information from the map itself. Looking at our map image, the coordinates are latitude and longitude. There is no datum information given, so we have to assume an appropriate one. Since it is India and the map is quite old, we can bet the average one at 30 datum would give us a good result. So I search for Everest and select the CRS with oldest definition of the Everest datum. Then I click OK. Name the output raster as 1870 Southern India Modified TIF. I choose LZW as the completion and then make sure the load in QGIS when done option is checked. After that I click OK. Now we can start adding the ground control points. The intersections of the grid lines will serve as the ground truth in our case. As the grid lines are labeled, we can determine the x and y coordinates of the point using them. I click at point and I click on the intersection. In the pop-up window, I enter the coordinate. Remember that x is equal to longitude and y is equal to latitude. I notice that GCP table now has a row with details of your first GCP. Similarly, add at least more GCP covering the entire image. The more points you have, the more accurate your image is registered to the target coordinates. The polynomial 2 transform requires at least 6 points. Once you have added the minimum number of points required for the transform, you will notice that the GCP now have non-zero dx, dy, and residual error value. Once you have satisfied with the GCP, I go to File and I click Start Georeferencing. This will start the process of wrapping the image using the GCP and creating the target raster. Once the process finished, you will see the georeference layer load in the QGIS. The georeferencing is now complete. It is a good practice to verify your work. How do we check if our georeferencing is accurate? In this case, you can load the boundary shapefile from the trusted source like the Natural Earth database and compare them. You will notice that match up pretty nicely. There is some error and it can be further improved by taking more control points, changing transformation parameters, and trying a different datum. This is the video for step 6, which is georeferencing topo shapes and scan maps. Thank you.